Why is it hard to find large prime numbers? Have you ever wondered why finding large prime numbers is such a challenge? Prime numbers are whole numbers greater than one that can only be divided evenly by one and themselves. For smaller numbers, identifying whether a number is prime is pretty straightforward. However, as numbers grow larger, the task becomes much more complex. One of the main reasons for this difficulty is that testing, if a very large number is prime, involves checking many possible divisors. This process can become quite computationally intensive as the numbers increase in size. With larger numbers, the gaps between prime numbers tend to grow in an irregular manner. This makes it harder to predict where the next prime number will appear. For smaller numbers, primes are relatively frequent and easier to verify. But when it comes to very large numbers, advanced mathematical methods and significant computing power are required to confirm if a number is prime. Traditional factorization methods become inefficient because large prime numbers cannot be broken down into smaller factors. Modern techniques have been developed to tackle this challenge. For example, probabilistic tests or specialized algorithms like the Primality test and elliptic curve methods are often used. These methods allow mathematicians to determine primality without exhaustive checking, making the process more efficient. The importance of large prime numbers extends beyond mathematics. They play a vital role in digital security. Cryptographic systems, such as those used in online banking and private messaging, depend on the difficulty of factoring very large numbers into their prime components. These systems generate large composite numbers by multiplying to large primes, and the security of this process relies on how hard it is to reverse it. Thus, discovering large prime numbers is not just a mathematical curiosity. It is essential for stronger encryption and safer digital communication. The difficulty in finding large prime numbers stems from the increasing complexity of primality testing, the unpredictable distribution of primes, and the computational effort required. This fascinating aspect of prime numbers highlights their importance in both theoretical mathematics and practical applications.